All right, now we want to look at some things that have actually been built, so I can convince all of you that this stuff actually works. The one we present a lot about is up in Denton. It's called Razor Ranch. It's a big, just a large commercial development that most of the time if you see one of these go in, it's going to be about a square mile of concrete with some buildings on top. And I just went to one the other day, and I was thinking about how they could have done things differently on this site to minimize. They're going to have huge pipes, huge detention coming off because it's so much concrete that a lot of their costs, a lot of their land really goes into maintaining, just treating not the water quality, but the quantity of runoff that's coming from your site. So Razor Ranch went about this using kind of an iSWM method, and I won't go into too much detail because I don't want to butcher what they actually did. But if you're ever up in Denton, make sure you go check it out because I think some of these BMPs that they've implemented are sustaining really well. You can see that they've done a lot of different treatment, what we call treatment drain, where like the filter strips Leslie was talking about earlier can't be used alone to meet water quality requirements, but they can help in conjunction with other BMPs to really get a high level of treatment. So that's one of the things they did on this, and then they've also got a big stormwater pond up on the northeast side of the site as well. So I'll just show some pictures of this. This is a bioretention area that was designed. It's just next to Walmart. So a lot of the runoff from Walmart goes into this. It's fairly large. You usually don't see a bioretention area this large, but when you have as much runoff as a Walmart parking lot is going to have, you either have a lot of them split up across your site, or you do it more as a almost a dry stormwater pond that has filtration capacity. And then here's a shot of that. I think that's the same. It may be a different one, but after a rainstorm, so you can see the ponding is working the way it's supposed to, and it's slowly filtering through that system. Another project, a little bit different than a commercial development. This is Merritt Road out in Rowlett, and this is something that Freese and Nichols has designed and is now under construction, almost finished with construction. And the bioretention areas that we designed on this one were in the median. So how we handled this is, I think, that's going to be pretty hard to see. But the cross section of the road down on the bottom of the screen there, basically we've got 2 lanes each direction, but we have a lot of off-site drainage, and so we're using a traditional inlet, curb and gutter inlet and pipe system to convey the flood storm for all the off-site drainage, but just like on South Lamar, all the drainage from the site itself is going to be treated and drained into a median swale that conveys runoff down to the bioretention area. And so we actually use a proprietary product on this one in Focal Point that Robin Neal so kindly sold us on, and that's a really cool way to implement these features in a smaller area as well. What the problem with this project is to use a typical bioretention media and to get the level of treatment we want for the volume of water that we want. It was going to be a pretty large area to do that in, and so the reason we use this proprietary product is we were able to shrink down the ponding area tremendously, almost 5 times the size that it would have been by using a higher infiltration rate on our engineered media. So it's cycling through the system a lot quicker. It's getting a different level of treatment than it would if it was there longer, but it's still the level of treatment that meets the requirements that the city asked for. And so basically what we're doing, we're draining to the median all the way down to the bioretention, and then it'll connect to that same traditional pipe system that's conveying all the flow from the offsite. Just a little plan view of the bioretention area. It's kind of hard to see as well. Here's a cross section, a little more zoomed in than the one on Lamar Street. So you can see we also used the Atlantis. Did we use the Atlantis rain tank on that one? Okay. So the rain tank is actually, it's got a lot of void space, but it's really strong, and so that's what we use as our under drain so we could also use it for storage and not just conveyance. And that's that box down on the bottom there that we use. That's where everything drains through the filter media and then into that box and then out to the pipe system. So here are a couple photos of construction of this thing. You can see that it's lined on the bottom in this area. And one of the things about this project is we use that moisture treated subgrade on the road, which requires a lot of over excavation. And so we lined between that so as not for the bioretention is also over excavated, and we didn't want the two, since they're not really connected to each other, we didn't want the two affecting one another, so we lined in between those two features. But then you can see on the right there the filter media being added in, and that standpipe there is a clean out pipe, so you blow compressed air through that and it goes through the Atlantis rain tank to clean out any debris that may have landed in there. On the left there, we're almost finished with construction, and then on the right you can see with minus the plantings, this is what it looks like. It's got the mulch on top. So you can see just a vegetated swale in the middle, in the median, that drains through that little rock check dam to slow down the velocities as it slowly goes into the bioretention area where it ponds and then slowly filters through. All right, moving on. EPA released a document. I can't remember what year this was in. It's starting to get a little bit dated, but I think there's some really good information in this document. They provide some case studies of a lot of different projects across the nation and how they used LID to treat stormwater to really change their project, and then they looked at the cost comparison of how that worked out versus traditional design. So Leslie later on is going to talk about the cost comparison on these two or I guess I have 3 of the case studies in here, but right now I'm just going to introduce the projects to you. If you have a chance, there's a link at the end. There's a link to this case study that you can go check it out on EPA's website as well. So this is Second Avenue. It's the SEA Street Edge Alternative is what SEA stands for. It's a program that Seattle implemented years back to try and really change the way they handle, especially their residential roads. So this Second Avenue is a road that they have implemented, and these are photos that they've taken after the system is very established, and they've done a lot of monitoring to show that it's working as well. So you can see their goals on this project were to obviously reduce runoff and then provide a more livable community. So what this was just a typical residential curb and guttered road through one block, and they said, let's take that one block, let's change it. And so what they did was 25 feet was the original width of the road. They shrunk it down to 14 feet. So it's really, when you look at it, it's really probably just a one-way road, but they provide a lot of little turnoffs and that kind of thing because it's a low traffic area, and the residents, from my understanding and what I've read, seem to love it. So I don't know how the fire department feels about it, but I haven't quite read anything on that yet. But they added a whole bunch of trees, 100 evergreen trees, and then about 1,100 shrubs to the area. Nothing too complex there. And then they did a lot of community outreach on this project to try and get community feedback and incorporate their ideas into the project as well. So what did this do for them? This pilot project more closely mimics the natural landscape prior to development. And then what they use the NDS approach, or the natural drainage systems approach. So it's basically another way to say low impact development or site design practices. What did it do originally? And let's try and mimic that in our design. So they had an 18% reduction in impervious surface from the traditional street. And this is the kicker here. Hydrologic monitoring indicates a 99% reduction in total potential surface runoff. So because they've depressed, they have a lot of ditches, but a lot of infiltration also. And I think they have obviously a little bit better native soils than we do in the area, so they can get a little more infiltration. But a 99% reduction in potential surface runoff is a huge deal for that area. And it's retaining more than the original design of 3/4 of an inch. Okay, the next project I wanted to look at is called Prairie Crossing Subdivision. It's up in Illinois. It's a 678 acre site with 470 acres of open space. So what they're going to do is 362 residential units, 73 acres of commercial property, and then schools, community center, biking trails, the whole works. So they and I'm not going to get into too much detail on it. I would encourage you to go read more on this project. But basically they just, instead of pipes, they used ditches, and instead of concrete sidewalks, they used alternative materials that were able to reduce their impervious area. And then they went back through and used structural controls as necessary. And really what I wanted to point out on this one was the cost that Leslie will talk about in a little bit. So the parking lot retrofits in Bellingham, Washington, they had two parking lots the city of Bellingham had, and they wanted, they were talking about using bioretention or other forms of treating flood control or managing the flood control in this area. And instead of, they were looking at underground vaults. Basically, they were going to store all their stormwater underneath the parking lots. And so they went back and evaluated, because that was going to be such a costly project. They evaluated using rain gardens, which is another form of bioretention, typically without an under drainage, just in an infiltration area. And they did it on two different projects. On the City Hall site, they used 3 out of 60 parking spaces for rain gardens, and were able to completely eliminate the need for underground vaults to store their runoff. And then at the park, they used a 550 square foot area converted to a rain garden, and also completely eliminated underground vaults. So using such a small amount of your space, but with just doing it wisely, they were able to save themselves a lot of money. And Leslie will talk about how much that really was in a little bit. So before we move on to the cost comparison, I just want to kind of summarize up to this point what all we've talked about. So low impact development planning, there are two components to LID. Site planning, which is we're just trying to reduce impervious area, we're trying to conserve resources, and mimic the natural drainage patterns that are on the site. And then once you've done that, you use the LIDs, stormwater controls, or BMPs, whatever you want to call them, to treat and manage the rest of your runoff. So the more you can do in component 1, the more you're going to save in component 2, the more you're going to save in your traditional pipe costs as well. I understand this LID principles don't work on every single site, especially in urban areas. You're not going to be able to reduce your impervious area in downtown Dallas that much. But at the same time, there are other things you can do, whether it be green roofs or storage, underground storage, and that kind of thing, that you can actually treat some of your runoff that's coming from those sites. So the next part is that LID is a change in philosophy and approach to stormwater management. I think we all probably understand that by now. One thing that we try and hit home a lot is that the developer in the city should communicate about requirements in the development process. This stuff doesn't just magically show up on plans, and I think if you're a city trying to review any plans like this, you realize that you don't just say, hey, developer, you have to do this now, and then it just happens. There's a lot of coordination that has to go through that. There's a lot of education that has to go through. And one thing also we were talking about during the break, not just with the planners, not just with the engineers, but once this stuff gets into construction, that's when you can design the heck out of a bioretention pond, but if you're not watching how it's constructed, it's not going to work out for you. So, and that was the case here on the Arlington side. It was the case at Merritt Road. So education of contractors as well, so they understand what's being implemented. And with that, I'm going to let Leslie jump in and talk about some cost stuff.